Let's look at this problem related to 9th grade circles. A circle has radius root 2 centimeters. It is divided into two segments by a chord of length 2 centimeters. Prove that the angle subtended by the chord at a point in the major segment is 45 degrees. Now I have taken a circle here. We have been given the radius of this circle is root 2 centimeter. It is divided into two segments by a chord of length 2 centimeters. So let us say that this is our chord AB of length 2 centimeters. We have to prove that the angle subtended by the chord at any point in major segment is 45 degrees. So I have to prove that this angle here is equal to 45 degrees. That is what we need to prove. Now let us say O is our center of the circle. Then we will join O to B and O to A. Let's drop a perpendicular from O onto AB. We know that by the theorem that the perpendicular drawn from the center to the chord will bisect the chord. And let us say this is M. So what is given to us? Given to us AB equals to 2 centimeters. That means I can say AM equals to BM equals to 1 centimeter. Also we know that OA equals to OB, which is equals to radius, is root 2 centimeters. So we have root 2 here, we have 1 here. Now let us find out what is the value of OM. So for that we will apply the Pythagoras theorem on triangle, any one of the triangles. Let us take OMB, we will apply Pythagoras theorem, then we know hypotenuse square equals to sum of the squares of remaining two sides. So OB square root 2 square equals to OM square, we don't know, plus BM square, which is 1 square. Now from that we can see that 2 equals to OM square plus 1, or OM square equals to 1. We will take only positive values, so OM equals to 1. So we got this also equals to 1. Then we know that AM equals to BM equals to OM. Now based on this discussion, now we understand that triangle OMB is an isosceles right angle triangle. Isosceles right triangle. If it is isosceles right triangle, then what happens? Base angles are equal. So this angle will be 45 degrees. This angle also will be equal to 45 degrees. Similarly, this will be 45 degrees and this angle is also equals to 45 degrees. Now once we know that both the triangles are isosceles right angle triangles, we can find out easily what is the angle made by the arc AB at center O. Angle AOB is equal to 45 degrees plus 45 degrees, which is equals to 90 degrees. So what we need to find out is angle made by the chord at any point on the major segment. This is minor segment, this is major segment. Now the theorem we know says that if this angle is 90 degrees, then the angle on major segment is half of 90, which is equals to 45 degrees. So we can write down our last step. Therefore, angle ACB is equal to half of 90 degrees, which is equals to 45 degrees. As we know that angle made by the arc at center is double the angle made by it at any point on the remaining part of the circle, which is nothing but major segment. So angle made by arc AB at center is double the angle made by it at any point on the major segments. Therefore, angle ACB is equal to 45 degrees.